Hi all. Today I'd like to walk through Cloudflare's concise Christmas cryptography challenges of 2019 and show some solutions. This was a very enjoyable way to spend a few hours over Christmas. The purpose of the challenges seems to be to advertise some cool stuff that Cloudflare are working on at the moment to improve the privacy and security of the internet. They do say that they are withholding answers until the start of the new year, since it is the new year now, and I'm sure that the 5 lucky people who submitted their answers first have long ago claimed their Cloudflare swag. I think we can dive in. So first challenge, client says hello. Immediately the title of the challenge should call to mind the first stage of the TLS handshake, where typically an end-user computer sends a packet containing a number of parameters for establishing a TLS connection to the server, including a list of supported ciphers, so a random seed for use in the cryptographic Diffie-Hellman key exchange, and then the server responds with a server hello. So we assume what we have here is a ASCII hexadecimally encoded version of such. So the very first thing I like to do is use my favorite text editor as a kind of IDE for manipulating data like this. First of all, pipe it through XXD, brilliant Unix utility for hexadecimal encoding and decoding. With the RP flags, that will take the ASCII bytes we have here and translate them into actual bytes. So we can immediately see some suspicious looking data at the end here. It's base 64 encoded data. And if I just decode that, it appears to be giving us instructions for how to proceed. We can also see here what looks to be a domain name, and the rest of it appears to be unreadable data. I'm just going to translate this back into hexdump format so that it's more familiar. And what I wanted to do here was to compare this to a typical client hello, and I think the best way of doing this actually is to try and capture one from my own machine. So what I'm going to do now is I'm going to grab some traffic straight off my network card. I'm going to go to cloudflare.com and then watch as the client hello there whizzes past. There's another one there to a different website. That's quite a lot of data. Anyway, we can use this one right here. So there you can see the host name, and Wireshark's useful protocol dissector, which you can see at the bottom there, is it's listing what each of these different fields correspond to. This is actually an extension, server name extension, and Cloudflare's linked blog post goes into more details about this. Basically, when you connect to an IP, there could be multiple host names on that IP, but each of them has a different TLS certificate, and the server needs to know which TLS certificate to present to the client, otherwise the handshake will not be able to continue. So this piece of data here tells the server which host name the client is requesting. Problem is, it's currently a privacy leak because this data is unencrypted. So over a decade since this extension to TLS was added, Cloudflare are actually working on encrypted SNI so that this extra piece of information isn't visible over the public internet, because at this stage of the TLS handshake, obviously the very first stage, there is no encryption going on. Anyway, going back to the challenge, just close this. What we have here is a host name which we probably should connect to, a path to get, and instructions to proceed. So if we do that, we are directed to Cloudflare's robots page and some lines of text on 4 and 5 which appear to be the answer. So moving on to question 2, time-based one-time password. This is a really useful cryptographic RFC I'm using a library here called PyOTP to actually handle the translation of dates and passwords to codes. What Cloudflare hints at here, and they don't give you a password for the TOTP, so it's kind of clear that the way to do this is to use a empty or null password. So in the code here, I've instantiated an object, a PyOTP object with an empty string. Just to backtrack a second, a TOTP is a kind of keyed MAC construction that uses the inputs of a password and a date, and even under the same password, every 30 seconds, the date will produce the changing date will produce a different code. So, as Cloudflare have written here, it's useful for authentication devices, but this one has a fatal flaw. So I've already done this code earlier, and I'm just going to step through it briefly to show you. So, adding in the data there that Cloudflare have provided, importing this useful library called DateUtil parser, which can understand dates in this kind of format and turn them into a Python date object. Then I'm iterating over the dates and the codes, passing the date, getting the code at that date using this brilliant library, and then asserting that the token that we get is the same as the Cloudflare provided one. And if I run that, if I run that, you can see no assertion failures, so that's working. And then all we need to do now is get the code at this midnight of January the 1st, which turns out to be 301554. So that was a nice challenge, kind of more testing our ability to string together a few libraries to get that working than to do anything that original. RPKI is something that's described in great detail in this article that Cloudflare have linked. But basically, the core idea is the internet's had some really high-profile BGP routing problems over the last year, where traffic from Google and Facebook has just been disappearing into various places where it shouldn't around the internet. So the solution proposed for that is RPKI, a kind of application of the public key infrastructure to the underlying routing protocol of the internet. So the way it works is it allows a IP block holder to authorize particular autonomous systems to originate their own routes, and as long as that's actually verified by the BGP and network providers, then it will work. But it does require quite a lot of adoption, and obviously Cloudflare, as one of the premier internet companies, is working hard to get that happening, which is great. So first of all, we need to find where we can actually get this data, these ROAs, which I believe are root origin authorizations. So that the way I actually got them was from reading a bit about how this data percolates through the internet. It starts at RIPE, the kind of internet forum, then it percolates down to the regional internet registries such as Afrinic, which is where I got the data. You can download a big JSON and then start parsing it for this secret message. So I'm just going to go back into the terminal here. As you can see, it's quite a big file. Useful utility that I love to use for parsing JSON is called JQ. Even just this command line is a very useful one to get a more readable output. The very first top level object there is ROAS. So I'm going to first of all get the array underneath that object. Then I'm going to look at the hints that Cloudflare provides, because actually it's not very clear where to start with this challenge really. So say 4 or 6, probably 6, IPv6. If only there were a way of listing only RIPs. Well, there's a list of their routes on their website. What if the only part of the ROA where we can hide information into? Well, I was a bit confused by that, because it seemed to me that you could probably hide information both in the autonomous system number and in the prefix, especially in an IPv6 prefix. You could put hexadecimally encoded data potentially. Anyway, final hint: subtract the reserve, the char will show itself. Reserve, I mean, there's such a thing as reserved IP addresses, but it's quite mysterious at this point. So I just dived in. I looked at the IP ranges for Cloudflare, which you can see on their website here. We want to try and just filter out this data. So the way I did that was to use some filters in JQ. So I want to filter that the IP prefix starts with this. Which seems to have done the job there. You can see it's only got a much smaller number of IPs there, 810. We also want to filter ones which start with, and rather than typing this out bit by bit, which would be quite painful, I'm going to use this FC shell built-in to drop us into an editor here, and then quickly build up the rest of this command with some Vim magic. Join these together, get rid of this. That looks good there. Apart from, we don't want these subnet masks either. So I'm going to do a find and replace of those. That was wrong. There we go. Okay, that looks good now. Let's try that. Okay, so now we have just all of the IPs that start with those. And I'm going to use JQ's -c flag to make it compact. Now we see that there's kind of some that stand out a bit. There's a few here that are a lot longer than the others, different max length. Got a very suspiciously high autonomous system number that's actually quite high, to 2 to the power 32, that what I believe is the limit on autonomous system numbers. The next step is to look at these a bit more closely and filter these out from the rest. So next thing I did is to grep for this. Just brings us a few. It looks like the prefixes increment up by 1, and the ASNs have this interesting looking few numbers on the end. So I want to kind of get these in a sorted order. Oops. So I'm going to use some, if I can remember, some string interpolation here to get this prefix first, then the ASN, and we don't really mind about the max length. So then here we go, and sort by the second column. There's still quite a lot of stuff there that we want to get rid of. We only really want these last few columns, but just for the sake of making this pipe even longer for fun, I'm going to use more Unix utilities to delete the AS at the beginning, delete the double quote at the end, and then read each line, echo just to start with, to show that to make sure we're doing the right thing here. And we want to take the common base of all of these 42 million. We want to echo this into BC command line calculator. This gives us the chars that we're looking for. Sorry, the ordinal versions of the chars we're looking for. And there's no good way of turning this into ASCII, as far as I know. But I do have a function off the internet that I've copied from earlier, which should be useful for that. Called char. So this gives us the final answer of Bravo, which is a nice end to this challenge. So thanks for everyone for watching, and thank you for Cloudflare for putting up these challenges. Sorry about the audio quality, but yeah, everyone have a happy new year.